This is block 1. Here we'll discuss why we need OpenFOAM and how to install it and run simulation with it. Let's get started. OpenFOAM stands for Open Source Field Operation and Manipulation. It is a tool used to develop customized numerical solvers for computational fluid dynamics applications. It is written in C++ and has the capability to integrate well with supplementary codes written in other programming languages like Python and Fortran. Unlike the commercial software like ANSYS, which focuses on applications and solving given problem, OpenFOAM is free, versatile, predominantly works well with Linux-based operating systems, and focus on developing customized algorithms and solvers based on the personal requirement of the customer. Though there are various claims on the inception of the FOAM project, the development of FOAM can be pinned to the early 90s. Initially, it was a commercial code. It was later converted to a GPL license in 2004 and renamed OpenFOAM. At present, various fork projects of the initial FOAM project is available widely, and the predominant bundles are variant developed by ESI group identified by year and month of release. For example, the latest version while recording this video is V2006, that is the version released in 2020 on June. The variant developed by OpenFOAM Foundation identified by version, for example V2.3, V4, V5 and V8. Variant FOAM Extend. Though there are no major difference in the base architecture of the program, based on the features required by the user, any version of OpenFOAM can be used. The functionalities of different versions are transferable with relevant programming knowledge. Various steering committees consisting of counterparts from industry, academia, user and consulting organization standardize the OpenFOAM framework. There are no clear possibility in the near future for a single unified OpenFOAM release version. The most important advantage of OpenFOAM is the free license, so the organization can focus on building necessary infrastructure for computing. Fully documented source code, user-friendly syntaxes and high-level parallelization helps organizations to switch to OpenFOAM in the present scenario, and making it a powerful competitor to available commercial softwares. The main disadvantage of OpenFOAM is the non-availability of integrated graphical user interfaces, which can be hectic for new users. The non-availability of a complete programming guide leads to difficulty for new users in the initial stage of transition. The disadvantages are being sorted out periodically or by innovative approach. Recently, many startups focus on providing a web-based simulation platform like SimScale and FlowFusic, which used OpenFOAM at the back end. These systems do not require the users to have necessary infrastructure for computing, but they can rent computing resources on core hour basis. With neat integration of GUIs in the web platform, the process of simulation workflow is made comparatively easy. Before going further, let us discuss something about the hardware. If you are a beginner user of OpenFOAM, then please consider using a computer which has a processor of at least Core i5 8th generation or higher. Optimum RAM capacity should be 8 gigs, but 4 gigs is also okay, with a minimum hard disk space of 40 gigabytes. There are no graphic card requirement for initial learning, and for this tutorial I'm using OpenSUSE Tumbleweed as an operating system, and the OpenFOAM version used is V2006, which is from ESI group, and it can be downloaded from openfoam.com. Though OpenFOAM was primarily designed to operate in Linux environments, recently bundles of Windows and Mac OS are being released. And make sure which version of OpenFOAM you are using. Each version of OpenFOAM is different and the simulation will have compatibility issues which has to be cleared. For example, OpenFOAM v2.3, which was widely used, has a different framework than OpenFOAM v5, and care must be taken on which version a simulation has to be run. When you need to run OpenFOAM in Windows environment, try using BlueCFD or the free downloadable version available at CFD support. In case of web-based environment for learning, SimScale has a free community account which has up to 3000 free core hours. And also, please note that new OpenFOAM bundles are often installed as image files with Docker. Though there is no issues in Linux environment, Docker will have performance issues when run on Windows. So take care of it. Now, before going into the video of the installation of OpenFOAM, let me make myself clear. Only installation of OpenFOAM v2006 under OpenSUSE Tumbleweed OS is explained in the coming video. Other installation instructions are available in OpenFOAM website documentations. So let's start with the installation. There are two reasons for me to choose OpenSUSE operating system. One is that I have been using OpenSUSE from my master's degree and I am comfortable with it. Second is that it has a science repository which is well documented scientific softwares, and installation is pretty easy. You can choose any OS of your wish, and the installation instructions are available on the OpenFOAM website, and it is pretty clear. Now let us start a console or terminal in the OpenSUSE main screen. We have to add the science repository because this is a clean installation and the repositories are not added. For that, we use the command sudo zipper add repo and then the link for which point out to the science repository. After adding the science repository, you have to refresh the libraries. So for that, you use the command sudo zipper refresh. And now the packages are updated, and you can see there is a key issue here. That's because you have to trust the key for the repository for you to continue, so you can just give trust always. Now the repositories are updated. Now you can just install OpenFOAM with the command sudo zipper install OpenFOAM. Here I am using OpenFOAM. This is very important because when you use OpenFOAM in your zipper install, it points out to the latest version of OpenFOAM being installed. For example, during the recording of this video, OpenFOAM v2006 was the latest released version. So now you can see that it installs OpenFOAM 2006, and also there are some additional libraries that has to be installed, which is pointed out, and you just press yes and then it will start installing everything. This command only installs the base of OpenFOAM, for example the libraries and solvers. It doesn't install the additional documentations. For that you have to install the latest versions. For that you use the command sudo zipper install OpenFOAM 2006, which is the latest version that's being installed dash, and then now you can see that there are a lot of other files that has to be installed along. So you just put OpenFOAM 2006 dash and star, and then all the other components will be installed. So now it is installed, and let us check if we have the OpenFOAM installed. Let's try the command icofoam-help. This should give out the help menu for icofoam, and you can see it just throws out an error saying that the command is not found. This is because that whenever you use a terminal to load OpenFOAM, you have to source the bash or C file of the OpenFOAM. which you have to do it initially, and every time when you want to when you open a new terminal, you just run the command bash, and the OpenFOAM environment should automatically load. So for that I am using Emacs here. As I don't have Emacs installed in this blank version, I am installing Emacs first, and after that Emacs I am opening the bash file. The default installation of OpenFOAM will be in user library OpenFOAM. You will find the bash rc file of OpenFOAM over there. Let's check if we have that here. Yes, we have the bash rc file, and then type the command cd, come to the home screen, and then now open the bash rc file with Emacs. So the command is emacs bash rc, and now you have to add the source command, source, and the link for the OpenFOAM bash rc file, and now you save and close the bash rc file. Now open the terminal and type the command bash, and now try the icofoam help command, and now you have the help section of the icofoam. So right now the OpenFOAM is made available in the terminal environment, and you can start simulating with OpenFOAM. The standard procedure is to create a foam run folder, which can be used to copy the tutorials or whatever files you need, and then you can run the simulations so that the results will be stored in the same folder. For that you have to first create the link. For example, here I am going to the home screen, and in the home screen I am creating a folder called OpenFOAM with the command mkdir OpenFOAM, and after that I am using the command foam run is equal to the folder name that I want to be a run folder. After this command, you can see that if I use it to call the cd $foam run command, it points out to the OpenFOAM folder in the home, which I'll be using to store and create files for my OpenFOAM simulations. Well, now with all this, you are ready to start running your simulations with OpenFOAM. To summarize, in this video you have learned the basics of OpenFOAM, how to install OpenFOAM in OpenSUSE environment, how to modify the bash file, and how to create a run folder for your foam run application. If you have any queries, post it in the comment section. I'll be glad to reply to them. Subscribe or follow my page to get updates for the next videos. Thank you for taking your first steps in learning OpenFOAM, and have a nice day. Till next video, bye from Arun.